Bismillahirrahmanirrahim. Assalamu alaikum, dear students. We have another topic of chapter number 13, that is 13.4 Amperes law. Okay. Ampere circuit law has two parts of two has statement which has two parts. In one part, he said that magnetic field and current both are directly proportional. Okay. For example, if we have wire which has 2 ampere current, so in this current will produce a small magnetic field, and we have another wire which has a current of 10 ampere. This current will produce a larger magnetic field. So it means the induced magnetic field will depend upon the magnitude of current. If the magnitude of current is smaller, small magnetic field will produce. If the magnitude of current is larger, larger magnetic field will produce. So magnitude of magnetic field is depending upon the magnitude of current. Okay. Another thing is magnetic field is inversely proportional to the distance. So it is inversely proportional to the distance r. Okay. What does it mean? It means if we have two magnets, suppose permanent magnets, okay, so both these magnets are far away from one another, the distance between them is larger. So if the distance between them is maximum, so their individual magnetic field is weaker. Their own individual magnetic field is weaker. But when I closer them, so the distance between them will be smaller. When the distance between them is get smaller, look at here, the distance between them is minimum. So if the distance between them is minimum, so look at the magnetic field. The magnetic field inside the magnet is from south pole to north pole, outside from north to south, inside from south to north, and outside from north to south. So look at here, the magnetic field of this magnet and this magnet is added, so the net magnetic field will be stronger. So it means magnetic field is a vector, and if the vectors are in same direction, they'll add it and will get a maximum resultant. So it means when the distance is smaller between the two magnets, then their magnetic field will be added and the magnetic field will be get maximum. Okay, the same is case here in the wire. If this is a wire and this is a wire, so both have the smaller distance between them. If both have the smaller distance between them, so this will produce a magnetic field and this will produce a magnetic field. So in the middle, both have the same direction, so both the field will be added, a maximum magnetic field will produce. So it means that when we minimize the distance between them, so the individual magnetic field will be added and the maximum resultant magnetic field will produce. So distance and magnetic field both are inversely proportional. Okay. So we have two statements. Magnetic field and current are directly, and magnetic field and distance are inversely. Okay. Combine these two relations, so we will get magnetic field is proportional to I by R, and if you remove the proportionality sign, so it will place constant. So that constant is mu naught by 2 pi I by R. So this is the magnetic field. Okay. So what is mu naught? Mu naught is called the permeability of free space, permeability of vacuum or air. Okay, and its value is for the air is 4 pi into 10 power minus 7 Tesla meter per ampere is its unit. Okay, what is meant by permeability? What is meant by permeability? Permeability means the allowedness. Permeability comes from permission. So the permeability means permission, yeah, allowedness of magnetic lines in a medium. Permission or allowedness of magnetic lines in a medium. What does it mean? It means if a medium has large permeability, maximum permeability means it would means maximum magnetic lines will pass. through that medium. If a medium has smaller minimum relative permeability, then small number of lines, small number of magnetic lines will pass through that medium. Okay, so it means that permeability means the allowedness of magnetic lines, and permeability depends upon the nature and temperature. Nature and temperature. Okay, permeability decreases with respect to temperature, so it depends upon the nature and temperature. Nature mean if a substance is paramagnetic, permeability will be greater than 1, diamagnetic permeability will be less than 1. So it depends upon the nature of the material. Okay. Let us consider we have a wire which has a current I and it is producing a magnetic field anticlockwise according to right hand rule. According to right hand rule, it will produce a magnetic field anticlockwise. Okay. This is the magnetic field anticlockwise, and there is an Amperian loop. Amperian loop should be in 2 dimension. Okay, so this is the Amperian loop which is in 2 dimension, which is circular. Okay, so now cut this Amperian loop into pieces so that it becomes a vector. It becomes displacement, instantaneous displacement. So cut this Amperian loop into different pieces so that it becomes straight displacement, instantaneous displacement. Okay, now now I am going to find the projection of this magnetic field on this Amperian loop L1. Now I am going to find the dot product of this magnetic field on this Amperian loop L2. These are the small displacements. Okay, because for the dot product there it is necessary to both the terms should be vectors. So I divided the Amperian loop into pieces that the circle, the distance, the circumference becomes the instantaneous displacements. So initially it was the circumference, means the scalar. So initially it was a scalar, so I cannot take the dot product of a scalar. So whenever I cut it into pieces, so it is a small straight lines, means instantaneous displacement. So it is a vector. Now I can take the dot product. So b dot l is equal to b1 l1 cos theta. And what is theta? Theta is 0 degree, and cos 0 is 1. So b1 dot l1 is equal to b1 l1. Okay, now I am going to find the projection of this magnetic field on this loop. So it will be b2 dot l2. So it will be b2 l2 cos theta. And what is theta? Theta here is 0 degree because the magnetic field is anticlockwise and the Amperian loop is also anticlockwise. So both are same in direction, so both are parallel. So b2 l2 cos 0 is 1. So it is b2 l2. Okay, cos 0 is 1. Now I am taking another projection of magnetic field on the Amperian loop. So it is b3 l3 is equal to b3 l3 cos theta. And what is theta? Theta is 0 degree. And what is 0? 0 is 1. So b3 l3. Okay, now what is the final projection? The final projection is bn dot ln is equal to bn ln. Okay, so I found all the projection of magnetic field on the Amperian loop. So now I am going to find the total projection of magnetic field on the Amperian loop. So I should sum it. So look at here, b1 dot l1 plus b2 dot l2 plus b3 dot l3 up to bn dot ln. Now I am going to add the right hand side. Now the right hand side is b1 l1 plus b2 l2 plus b3 l3 plus up to bn ln. Okay, now I am going to write the left hand side in summation form. So it will be summation bi dot li, where I runs from 1 up to n, is equal to b1 l1 plus b2 l2 plus b3 l3 up to bn ln. Okay, now as the magnetic field circling around the current is constant, so can I write is equal to b1 is equal to b2 is equal to b3 is equal to b4 up to Bn up to B. So the magnitude of magnetic field at each and every projection is same. So I'll write this equation as BL1 plus BL2 plus BL3 up to BLN. Okay. Now take B as a common, so it will be L1 plus L2 plus L3 up to Ln. Okay. Now look at the left hand side, summation of Bi dot Li, where I runs from 1 up to n. Okay. Now I am going to take the summation of this. So it is Li, where I runs from 1 up to n, and the left hand side is Bi dot Li. Okay. Now the total length of the Amperian loop is 2 pi r, because it is circumference. So it is 2 pi r. And what is B? We already studied that B is equal to mu naught by 2 pi I by r. This is the value of B. So putting the value of B here, so it will be mu naught by 2 pi I by r, and circumference is as it is. So 2 pi r and 2 pi r will be cancelled. So it is mu naught I is the projection of magnetic field on the Amperian loop. So this is called Ampere's circuited law. This is Ampere's circuited law. What does it mean? It means the projection of magnetic field on the Amperian loop is totally depending upon the nature of the medium and the current flowing in the wire, the current flowing in the circuit. So this is all about Ampere's law. If you have any queries, so you can ask. Take care. Allah Hafiz.